Welcome to Transcended Institute. In this tutorial, we are going to solve Math 11:20, that is tutorial sheet 1 under set theory. So the first question is saying let E, that is the universal set, be equal to X be a member of integers, then X should be less than X and X should be less than or equal to 8. Be the universal set. Given that A is equal to, they are saying that X should be a member of E, okay, then they are saying that X, so E maybe is real numbers, yes, and then they are saying that X is a factor of 12, then B should be 2 3 4 or 2 3 5 6, and C should be 2 1 and 5. I think that's all. Then find each of the following. So now it's very important for us first to understand what it means when you're talking about the universal set. So the universal set here, when we say 1 is less than X, then X is less than or equal to 8. What does it mean? So if I tell you that 1 is less than X, it's basically the same as X is greater than 1. So I've just flipped this. Okay, we have started. You have seen, right? So now what is happening here is simple, guys. So what I'm trying to do here is we are trying to look at the numbers which are X should be greater than 1. So meaning that this universal set, I'll write it from here. I'll say that this universal set E, it is, so X should be greater. So now this is X should be greater than 1, but X should be less than or equal to 8. So 1 is not included. I'm going to start from 2. So it will be 2, 3, 4, 5, 6, 7, 8. Now 8 is included. So that is my universal. Now you should also be careful here. The question is X is a member of Z. So Z is basically integer. So integers start from there. These are positive and negative numbers. So these are integers. Negative 2, negative 1, 1, 2, 3. Those are integers. Okay. So 2, 3, 4, 5, 6, 7, 8. This is our universal. Now let us also look at A. Set A. I'll write set A here. So what is A? A is telling us that it's a factor of 12. So what do we really mean when you say numbers a factor of 12? A factor of 12, these are numbers that goes into 12. So from the universal which we have, which numbers goes into 12 without leaving a remainder? Okay, so I can clearly say that 2 goes into 12, 3, 4, and 6. 8 doesn't go into 12. It's going to leave a remainder. So the factors are 2, 3, 4, and 6. As simple as that. Now, next thing after knowing our A to say is 2, 3, 4, 6. Then what is our B? B we have been given. So I'll just write it here. And B it is 2, 3, 5, 6. What else? Let's also write C. So what do we have on C? C is 2, 4, 5. 2, 4, 5. Like that. Now, the next thing that we have to do is this. The next thing that we have to do is, let's now look at question A. Part A is saying A minus C. So minus simply means intersection, and then you have to put complement on C. So it is basically A intersection C complement. Now it is very important for us first to identify what C complement is. Okay, so C complement, what is my C complement? C complement, these are numbers from the universal set except the numbers which are found in C. So now I'll go to universal and then I'm going to cancel the numbers which are found in C. So in C I've got 2. I'll cancel 2. 4, cancel 4, 5. What numbers have we remained with? We have remained with 3, What else? 6, 7, 8. This is C complement. Okay, so if that is C complement, and then which numbers are found in A, in set A, and in C complement? Let's check. 2 is not there, 3 found in both. So then the answer for A minus C is going to be, the first one is 3. 3 is found in both. 4, there is no 4, but 6 is there. And then I'll write what? 6. Okay, so you see, it is very easy if you manage to just list C complement and look at the numbers which are found in both A and C complement. So in this case, this is my answer. So now there are two things here. Is either you can say A minus C is equal to this, or A intersection C complement is equal to 3,6. As simple as that. Now, using the concept for part A, I believe we can be able to solve part B. Okay, so let us try to crack part B. So part B is saying B minus A in the brackets, then intersection C. So this is basically the same. When there is minus, then you use intersection. So it is intersection A, then just put complement here. We follow the same principle, intersection C. What does it mean? The first thing, let's first deal with what is in the brackets. So first, let us first deal with the complement. What is A complement? So A complement, I'll come here. My A complement, the numbers which are found in A, so we exclude them. So we're excluding 2. 2 has gone. We are also removing, okay, we are also removing 2 is found in universal, we can't write it. 3 is found in A, so we can't write it. 4 is found in A, we can't write it. 5 is not there, comma. 6 is there, we can't write it, but we have 7 and 8, like that. Okay, so now what we have now, A complement. So now we want to intersect the numbers that are found in A complement and B. So A complement is here and B. So B is this one. Okay, the only numbers which are found in A complement and B, it is 5. So I have got 5 intersection. Again, what numbers are found in C? The numbers that are found in both this and there, we also have 5. So it's 5. So the answer here, you can clearly see, guys, that the answer is basically 5. Okay, so the answer is 5. So the most important thing is just to know what a complement is, then you are done. Now look at part C. So if you look at part C very carefully, you are going to see that when you have got a complement outside the brackets, we bring the complement inside. Okay, so A intersection C, then complement, it is basically the same as A. When you bring the complement inside, this intersection will change to union, so it will be like this. So it's like you have this. So if you want, you can put the brackets, but in this case I'm not going to put the brackets. So we want to find the numbers. I'm going first to rewrite my A complement. A complement, the numbers that are not found in A, 2 is found in A. Okay, I'm not going to write it. 3 is found in A, I'm not going to write it. 4 is found in A, I'm not going to write it. 5 is not found in A. 6 is found in A, then 7 and 8, like that. Then let's write also C complement. So C complement, the numbers that are found, 2 is there, we can write it. 3 is not there, we'll write it. 4 is there, we can write it. 5 is there, we can write it. 6 is not there. 6, 7, 8. When we're talking about union, we are just getting the numbers that are in A complement and in C complement. Okay, so it is something that is not complicated at all. So there we go. We are going to write the numbers now. So the numbers which are found in both A complement and C complement, I'll start with 3. Which other number 5? Which other number 6? Which other number 7? Which other number 8? So this becomes my answer. Okay, now let us try to crack D. I want you guys to go ahead and solve D. So I want you to go ahead and solve D. For the fact that I've solved B, it is the same concept. And I also you guys to go ahead and solve part F, because F and the C, they're basically the same. So try to solve D and F. You can either send the answers in the comment section, I'll be able to see them, or you can send the answers in my WhatsApp, in my inbox if you have my number. Okay, so let me just go ahead and solve E. So I've given you an assignment, try to solve D and F. I'm going to solve for you part E. So let's go ahead and solve part E. So E is A minus B intersection A complement. What else are we supposed to know? So what we have, this is the same as A. When there's minus, put intersection B complement. I'll do it like that, intersection C complement. Let us first go ahead and find B complement and C complement. So I'll do it from here. Let's start with B. So B complement, it is basically 2 is in B, we can't write it. 3 is in B, we can't write it. 4 is not in B, I'll write it. Okay, what else? 6 is in B, I can't write it, and then I'm going to write 7. Then I'll also write 8. That is B complement. What of C complement? C complement, we wrote it, but I have dubbed it, so it's fine. So C complement, here 2 is there, we can't write it. 3 is not there, I'll write it. 4 is there, 5 is there, I'm not going to write it, but 6, 7, 8. Now we want the numbers which are found. The first thing is we are trying to find the numbers which are found in A and B complement. A is 2, 3, 4, 6. So we can clearly see that the numbers which are found in A and B complement, it is only 2. Not so. Okay, let us see. So that is we are now trying to find part E. Okay, we are now trying to find part E. So the numbers which are found in both in both what? So the numbers which are found in both A and the B complement. So B complement is 4, 7, 8. Then A, it is 2. We have 2, 3, 4, 6. So it is only 4. Yes, so it is 4. So we intersect it with C complement. What is my C complement? My C complement is this. My C complement is 3, 6, 7, 8. I can clearly see that there are no numbers which are found in this and that. So therefore this is empty set. Interesting, right? So this is how you go about question 1. So try to solve part D and part F. Yes. And then you send me the answers and I'll be able to check the answers which you are going to find. Okay, so that is it for question 1. So question 2 is saying let A, let A is equal to B equal to 1, 3, 4, 6, B equal to 2, 4, 6, 8, 10, C equal to 1, 4, 5, 6, 8, and let the E, that is the universal, be equal to 1, 2, all the way to 10. So be the universal set. Verify. So we're just verifying. It's something that is easy, guys. When you're trying to verify, meaning you have got two parts. You have got left hand side and the right hand side. So I'll start with left hand side. So I'll say left hand side. I underline it like this. So we are trying to find what A intersection, open brackets, B intersection. So the first thing is we need first to find I'm first going to list set A. So set A, I have got 1, 3, 4, 6. So I intersect this. Now I need to find what A or B intersection C is. So C is this. I've got B here and I've got C. The numbers that are found in both C and B. So 2 is only found in B, 4 is found in both. So I'll write 4 here, comma. 6, voila, it's not there in C. 8, oh no, 6 is there, sorry. 6 is there in set B and C. What of 8? 8 is there in set C, so comma 8. What else? 10 is not there. So I think this is what I'm going to have. Now, after having this, what else are we going to consider? Let us see. Okay. So let us see now. We are going to have now, so what will be our intersection? The numbers that are found in both, that should be 4 and 6 only. So we can clearly see that A intersection open brackets B intersection C is the numbers that are found in this guy. This is A and this is B intersection C. It is only 4 and 6. So it is 4, 6. So we are verifying what we have here. We should find the same things when we come to right hand side. Okay, so right hand side we have got A intersection B. So what I'm going to do is I'm going first to find A intersection B. So A is 1. Well, let us find the numbers which are found both in A and B. So A is 1. Okay, so A is 1. What else do we have? A is 1. We have got 1. 1 is not in B. 3 is not in B. 4 is in B. So it is 4, comma. 6 is in B. I'll write 6. Then I intersect it with C. What is my C? My C is 1, 4, 5, 6, 8. Like that. So the numbers that are found in this and that, it is 4, 6. We can clearly see here. So we also know that A intersection B, then intersection C, it is 4, 6. Hence verified. Okay, hence verified. So now what is happening here is we have verified the first one. So now when you verify this, you know guys, the method that I've used here, this same method that I've used here, I want you to go ahead and try this question. The same method, but I'll go ahead and also try B. But the B, I'm going to do just the first part. Okay, because I want you to be familiar with what we are doing. So try to do this one. When you're talking about union, you are just keeping them together. Or maybe let me just do it for you. Okay, let me do it for you. So A, now this is union. So this is the simplest one. Left hand side. So what is A? So A, in fact here we're just talking about union. So A union B union C, we are just getting all the numbers that are found in A, B and C. That's all. Okay, but if a number appears twice, you write it once. So A, we have got 1. What else do we have? So we are just writing everything here, everything there, everything there, but in order. So it is 1. Next is 2. Do we have 3? Yes. Do we have 4? Yes. Do we have 5? Yes. Do we have 6? Yes. What of 7? We don't have 7. Yeah, there is no 7. in all the sets, but we have 8. Yes. Do we have 9? No, but we have 10. So that is basically A. Okay. So that is, so we have just to write 1 2 3 4 5 6 8 10. Then right hand side, I underline it. We are finding, again it's the same thing. That's why this one is just dialect. In the brackets, union C. So if we are dealing with union, you just write the numbers but in order. In this case it's 1 2 3. I'm also following the same, comma 8 comma 10. So hence proved, you have seen. So I've verified. So for part A, that is it. But let's try to do, if you do part B, I'm going to do the first one, then the second one I want you guys to do, and then you verify the answers with me. So we have A, left hand side, A intersection, open brackets, B union C. So the first thing is, we first have to write what A is. A is 1, okay, 3 4 6. That is A. So I have to intersect this with B union C. So B union C, I'm just writing B and C together. So I'll start with the list number 1 2. There is no 3. Then I'll jump to 4. There is no 5. 5 is there. There is 6. Yes. Do we have 7? No, but we have 8. Do we have 9? No, but we have 10. Okay. So the numbers that are found in both, we can clearly see that we have 1, yes, 2 no, but 3 no, 4 yes. What of 6? 6 is there. So this is A intersection, open bracket, B union C. Okay, so we have to find the same answer when we want to find, so 1 4 6, yes, we want to do the other one. So the other one is this now. So it is A intersection B, then union, then we have A intersection C, like that. So the first thing is we need first to find A intersection B, the numbers that are found in both A and B. So what are those numbers? A, we have 1. 1 is not there in B, so it's not the 1. 3 is not there in B, it's not the 1. 4 is there, so I'll write 4. Okay, what else? 6 is there, so I'll also write 6. Then I write union. Then what of A intersection C? So A1 is found there, 1. Then what else? 3 no, 4 is there, then also 6. So union, we are just writing everything to be together, so that will be 1 4 6. So this is my answer. So you can clearly see that the left hand side and the right hand side, they are the same, hence verified. So you guys go ahead and do this part and try to type the answer in the comment section, or if you have my number, just try to inbox me. I'll be able to check your answer. Let us try to go to C, the last one for question 2. So we are still verifying. Now we are verifying De Morgan's law. This first one, it was the distributive law. This first one, it was associative law. Then distributive law, De Morgan's law. Yeah, so let us try. This one I'm going to solve again. The first one, I want you guys to come and verify this part. Okay, so now we are trying to do A in union B, but we have complement to see that this is equal to A complement intersection B. So initially they are just telling us to say all the numbers that we have, we remove A union B. That's what they are telling us. Okay, so let us see. Okay, let us see. So we are trying to remove A union B. So the first thing that we have to do is we need first to find what A union B is. Then we remove it. Okay. So the first thing that we have to know, guys, is my A union B without complement. Okay. So let's first go to universal. That will be better for us. So the universal is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is my universal. So this is my universal, but I have to remove A. So in A we have got 1, I remove 1. What else? We have got 3, I remove 3. It's a complement, so I'm removing. Okay, I remove that. Oh, first, before we even let's make things clear. Let us first do this. What is A union B? So A union B has to be, what are the numbers which are found both in A and B? It is 1, then we have got 2, 3, 4, 5 no, but 6, then 7 no, but 8 and 10. Now we have to remove its complement. We have to remove this. Okay, so we are trying to remove this. So if we remove this, we will only remain with, we are going to remain with 5, okay, 7, okay, and 9. That's all. These are the numbers we're going to remain with. So meaning that A union B in the brackets complement, it is 5, 7 and 9. Okay, now we also find first A complement and B complement. So A complement, the numbers that are found in A, but we remove them. 2 no, so I will write 1, 2 no, then I'm going to write 3, but 3 no, because okay, yes, so we're talking about A. Okay, A complement, let's just do it. A complement, so I need to remove 1, I need to remove 3, I need to remove 4, I need to remove 6. That's all. So A complement is 5, 7, 8, 9, 10. What of B complement? B complement, I need to remove 2, so I'm going to use a different color now. I remove 2. What else? 4. What else? 6. What else? 6 and then 8. What else? 10. The remaining ones are 1. Okay. 1, 3, 5, 7, 9. So now we want to find A intersection, or A complement intersection B complement. The numbers that are found in both there, we have 5, 7 and 9. As you can see, we have verified. So the left hand side, this is the left hand side and this is the right hand side. So we have verified. So you can do the same for this one. You are going to say A intersection B. So what A intersection B, but remove it and then see what you are going to have to the other side. It's not that difficult, guys. Or maybe let me try to do this one for you. Let me try to do this one for you. So in the universal, sorry, A intersection B, it is basically the numbers that are found in both A and B. 1 no, 2 no, but 3 no, 4 is there, 4 and 6 only. So we are only removing these. That will be now. Okay, so in A intersection B complement, so we are removing the intersection. So we're only removing 4 and 6, but the rest we have to write. So it is 1, 3, 4 no, because it is in the intersection. 5, since it's not in B, so I'm not going to consider it. 6, it is in the intersection, I'm not going to consider it. But 7 no, but 8, then 10. That is what we have. Okay, what else are we supposed to know? Another thing we'll go to now, the other side. So we are just saying a complement. So let's first list what a complement is. So a complement, we're only moving 1, then we write 2, 3 no, then we write 4, 5 yes, 6 no, because it is in there, then 7, 8, 9, 10. Then what of b complement? Okay, let's see, is this going to be correct? So I have only made one mistake here. We are only removing a, the first one here. Before I even finish here, we are only removing 4 and 6 and write the rest. Okay, I think that makes sense. So a intersection b, okay, a intersection b. So a intersection b, the numbers that are found in a and b, so it is only 3 no, but 4 and 6. So we are only removing 4. Okay, then a complement, now I'll write from here. We are only removing 4, the rest we have to write. We are only moving 4 and 6, the rest we have to write. So the rest are 1, 2, 3, 4 no, but 5, then 6 no, but 7, 8, 9, 10. That is what we have. Now what is a complement? A complement, we are only excluding the things that are in a. 1 is in a, I'm not going to write it. 2 is not in a, I will write it. 3 is in a, I'm not going to write it. 4 is in a, I'm not going to write it. 5 is not in a, I'm going to write it. 6 is in a, I'm not going to write it, so I'll write 7, 8, 9, 10. Let's go to b complement. B complement, so this is now my left hand side. B complement is 1 is not there, I'm going to write it. 2 is there, I'm not going to write it. 3 is not there, I'm going to write it. 4 is there, I'm not going to write it. 5 is not there, I'll write it. 6 is there, I'm not going to write it. 7 is not there. 8 is there, I'm not going to write it. Then that is what? Now 9 is not there, 10 is not there. So union, we have to write everything together. So therefore a union a complement union b complement is 1, 2, 3, 4 no, but 5, then 6 no, 7, 8, 9, 10. So we can clearly see that what we have here is basically the same as what we have there. Hence proved. Done. So that is it for question 2. So let us now go ahead and talk about question 3, which is saying given that the universal set is the set of all real numbers. So immediately when you read the question and they're telling you that the universal set is the set of real numbers, what they're trying to tell you is that it's from negative infinity to positive infinity. Use the set A to be equal to from negative infinity to 2 not included union 4 to 8 both included, then B negative 7 included to infinity to verify De Morgan's law. So what is De Morgan's laws? So De Morgan's laws, we know that A intersection B in the brackets complement is equal to A complement union B complement, like that. So the first thing is we are going to look at this, we find the answer, we also find the answer for that. So for now, let us focus on A intersection B in the brackets complement. So you know, the best thing that we can do, guys, is the best thing that I'm going to do, I'm going to use a number line. So it will be very much easy for us to follow if I use a number line. Okay, so the set of real numbers, so we have negative infinity to positive infinity. Okay, so then what I'm going to do, just to separate these numbers, I'm going to put a 0 here. What other numbers do we have? So negative side, we have got negative 7, that's all. So I'm going to put negative 7 here. Positive, we've got 2, 4, 8. 2, 4, 8. So I'll put 2 here, 4, 8. Okay, here I put 8. Another thing that we have to do, we are looking at A intersection B but complement. So what is A intersection B? But the first thing is, let us first get our A. So our A is from 2 to negative infinity, not included, all the way to negative infinity. Okay, that is A. But again we jump, then 4 included, all the way to 8. That is again my A. So this is A, this is A. Okay, then another thing that we have to look at is B. So B is from negative 7 included, okay, all the way to positive infinity. That is B. Now we are looking at the intersection, so we are just removing the intersection. So the intersection is this part. Okay, so then upper we jump again, we come here, that is again the intersection. So the part, this is the part that we don't want. Okay, so we do not want the part that I've shaded red. So then the part that we want now, since this last line it is included, then now the other one we want is not going to be included. So we open, it goes there. We want that part, that will be now the complement. Then again this part will not be included, but this part, oh sorry, this part will be included because here the last line here it is not included. So the part I want, it will be included, but this one is, since this is included, the one I want is not going to be included, so it will be open like that. I want that. Then again from here, from this point, it is not going to be included because that point is included all the way to positive infinity. So the part which I want, it is from negative infinity. Where can I write it? I'll write it from here. I want from negative infinity. Okay, I'll write it from negative infinity all the way to negative 7, but negative 7 is not included. Then union, I jump, then I'll come now, 2 should be included all the way to 4, but 4 not included because of this line. So then again starting from here, 8 union, again not included all the way to positive infinity. That one is the answer for A intersection B. Then we have to put what? The complement like that. Okay, I hope it's making sense. Then what other things are we supposed to consider? Okay, so this is the answer for A intersection B in the brackets complement. Then again, let us also find, so we have verified now that is the answer. Let us also go ahead and find A complement intersection B. So I'm going to get rid now of these things which I have on the number line. I'll just remove this. I'll leave the number line the way it is. So we want to verify De Morgan's law. So let's try to find what A complement is. So A is basically from negative infinity to 2. Okay, then we are jumping 2, then or 4 to 8. So the A complement is the 2, since it's not included for A, so the complement will be included. Then 4 is not included, or 4 is included, the complement is not going to be included. This part here is my A complement, but we're not done. And then from 4 to 8, but again 8 is included, so the complement is not going to be included, going there. That is again another A complement. Let's go to B. Okay, so B is now we're trying to get B complement. So B is starting from 7, but 7 is included, so meaning complement is not going to be included, it has to go all the way to negative infinity. Another one, since this has to come all the way to positive infinity, so the union, when we're now adding them, it is just this part, we jump this part, we jump this part. So that part we can clearly see that it is from negative infinity to 7 not included, union, so 2 will be included, then comma 4 not included, union, 8 not included, all the way to positive infinity not included. So this is the answer for that other one. So you can either verify this without using the number line, but I feel like using the number line is a bit easier. It's much easier to understand it or to follow it. But you can also find the answer without using the number line. So basically that is it for this question. Okay. I hope you guys are enjoying this video, but I just want to show you how best you can actually access our full topic videos, the full topic tutorial sheet solutions, and also many more. So if you go on Google or Chrome, just search transcended, okay, then it's going to come. Yeah, so if you go to our website, our learning site, you're going to see that we have almost everything that you are supposed to. For NS, we have got biology, chemistry, physics, and math. So for example, you are watching mathematics right now, I'll just click on math, and then I show you the full topic videos that can also help you to understand more. So we have got set theory, we have got complex numbers, functions, exponential and logarithmic functions. So all the topics that you are supposed to know, they are here. We also have the tutorial sheets, the past papers, and the recorded class. So anytime we have a class, we do record and then we put them here. Okay, so for those of you who want to register with us, just check the link in the description below. You'll be able to find it, or you can just go direct to our website. If you just go on Google, type Transcended Stud Hub, you'll be able to find it. And then down here there's a number that you can call. If you don't want to call this number, you can either get in touch with us on using this email address, but the best way is just to click on this WhatsApp icon. Once you click on this WhatsApp icon, it's going to take you direct to the WhatsApp number. Then you can text that WhatsApp number then you can do it if you're having some challenges. But you can also register without contacting anyone, because you can just click on any video and then it's going to show you subscribe. Then you can pay using the website, unless if you're going to have some challenges, that's when now you can come back here and click on this icon. Now make sure that when you register with us, make sure that you are added to the registered group, because it is that group that's where we post almost like everything for NS and the announcement for the classes. Okay, so let's continue. So let us go ahead and also solve question 4. So this question is under set interval notation. The question is saying let x be equal to negative 10, 10 be the universal, that is the universal set, given that a is equal to negative 2, 7, okay, and then b negative 6, 6 union. We have that now. So what else are we supposed to see? C is equal to that. For each of the following sets and or sets, and display it on the number line. Find each of the following sets and display it on the number line. Okay, so let's try to crack this question. Let us try with part A. Okay, so part A is what? Let me first put it in this form. I need to use blackboard, like always we do that. So let us first use the number line. But first, before we go to the number line, we should take note that A, C minus B, it is the same as C intersection B complement. So we are only getting rid of C. Oh, sorry, we are getting rid of B. Okay, so let us now go ahead and use our number line. So here is my number line. Okay, so this number line, I'm not going to put arrows because I've been told that it ends on -10 included to +10. That is my universal set X. So I'll say that is X. So let us now go ahead and look at C. It will be easy. So what do we have for C? C is 3 to 10. So let me put 0 just in between to differentiate between negative and positive. Okay. Or to make things easy, I can put 0 here. Then here I'm going to put 3. What are the numbers? I'll put 6. What are the numbers? I'll put 8, 9. Then I have got 10. Done. So then the negative side, what numbers do we have? From I'm interested in C and B, -6 only. Then what we have to do now is let us go ahead and write set C before I go to B. Set C is 3 to 10. 3 not included, to 10, 10 is included because it's part of the universal. That is set C. Now let us go ahead and do B. So B, it is -6 to 6. So -6 is here, included, all the way to 6, included. I'm going to put here, that is the B. But we have to jump. Now I want you to be careful here. This is now not an interval. This is telling us that there is a number, there is a point at 8, there is a point at 9. Okay, so at 8 I'm going to put a point, at 9 also a point. I can't put a line in between, because if I put a line, meaning I'm telling you that the numbers from 8 to 9, but in this case it is 8, 9. So then they have used this. This is not an interval. So you just put a dot showing that set. Okay, so like I have done here. So this is B, again this is B, again this is B. Now we are talking about the complement. B complement. If this is B, B complement, if this is included, this is not going to be included all the way to that point. Same, I'll just follow the last part. This point here has to be open. Even at this point it has to be open, because I'm not supposed to include at 8. Even here I'm not supposed to include 9. Even here it goes there, I include that. Now I can put the point. What does it mean? B, so this is also B complement, and also B complement. What it means there is that at 8 there is open, meaning 8 is not included. At 9 is open. So it is intersection. We want the part where it is intersecting with C. We are not interested with this line, although that is also being complement, but we're not interested. There is no line for C this side, but we want the line where this C and B complement will meet. It is at 6, this point. Then when I reach here at 8, I'll jump again, I'll go here. When I reach at 9, I'll jump again, I'll go there. That's what it means. So the point that I'm interested in, it is this point. I jump there, that point. I jump there, that point. You have seen. So that would mean to say my answer is, for C minus B, my answer is 6, but 6 is not included because we are following that. It is open, not included, 6, comma. I reach at 8, 8 not included because 8 is part of B, sorry. So I cross again. Then union, again starting from 8, I'm starting from 8 again, I go to 9. Not included. Then union, again I'll start from 9 all the way to 10. But now the last one is included. So this is my C minus B. That's the answer. It's interesting, right? Very interesting, actually. So it's just a matter of you understanding what is happening. Now let us go ahead and also do part B. Part B is actually interesting. It's very interesting. So B minus A, we intersect with C. It's the same as B intersection A complement, then we intersect it with C. We use the number line as usual, the universal 10, negative 10 to 10. So I'll put 0 here to differentiate the negative and positive. To make things easy, I'll put negative 0 here. So that's my x. So in positive x, I'm dealing with all of it, and then I've got negative 2 and negative 6. What other numbers? The positive number that I'm dealing with 3. What else? 3. What else? I'm dealing with 3, 6, 7, 8, 9, and 10. Okay. So let us first write A complement. So A complement, we are just excluding negative 2. And so A is basically, I'm going to write just a faint one to show you where A is. A is from negative 2 to 7. So a complement, that is A. We're not interested in A, but we're interested in the complement. So the complement, starting from here included, all the way to that included, that is A complement. Another A complement starting from here included, all the way to negative 10. So now we don't put arrows, but it ends there. I'll put A complement. So when I do that, I'm not interested in A. So if I want, I can, okay, you can leave it for the sake of you following it up. But if I want, I can remove A because I'm not interested in A. Like that. Then if I want, I can just drop this down a bit. Even this one, I drop it down a bit. That is A complement, A complement. What is B? So my B is from negative 6 included, all the way to 6 included. Okay, that's B. But again, it jumps union 8, so we just put a point at 8, and again we put a point at 9. That is also B. Then what else? We want to intersect it again with C. C is 3 all the way to 10. So 3 not included, all the way to 10 included. So this one is this one is interesting, guys. So that is C. You can clearly see that we want the point where B, A complement, and C, they are meeting. A point where all these three meets. So I can clearly see that this point here, I have at this point here, I only have two things. This point I only have A complement and B, so I'm not interested in that. Or this point, then this point I don't have A complement. Okay, but the part where all the three guys are meeting, it is this part. There is this line for C, this line for B, and this line for A complement. Now I can't put this in interval because I only have one point at B, so I'll follow that. Okay, so I'll open it like that. I'm going to follow now this. I'm going to say at 8 I have got a point. Again at 9 I've got a point. You see? So then these are just points. I can't put it in interval. When I put it interval, meaning I'm telling you to say from 8 to 9, but it's just telling us that at 8 there's a point, at 9 there's a point. So this is the answer for this question. It's interesting, guys. Now I think you can go ahead and do part C. I know nothing is going to be hard because there is no B. Definitely you can do part C. Okay, part C you can do it, guys. You can definitely do it. So the answer for this is C. You don't use the intervals, you use these. So 8 comma 9, that's the answer. Okay, so now part C is just direct, as we can see. It is A intersection B intersection C, like that. That is the same as A complement union C complement. So A complement, we just A is basically not included at 2, -2, but complement will be included. It goes there again, included. That is A complement. Again from 7 it will be included, again to 10 included. That is A complement. What else? What of C complement? C complement, C is 3 to 10, but 3 is not included, so the complement will be included. Going here, we end there. That is C complement. This side is not going anywhere because it goes all the way. C is just here, so we don't want that part, but we want the complement. Now union, we are adding everything. So A intersect it with C, and then complement, it is basically from -10 all the way to 3, because it just coming here is union, so we are adding everything all the way to 3. Again 3 is included, union. Again we start from included 7 all the way to 10 included. I hope that is not a problem. Okay, yeah, I hope that should not give you a problem. So -10 to 3 both included, 7 to 10 both included. Okay, now I'm not going to do D, but I believe you can do D, guys. So try to do D, but what I'm going to do, I'll request you to send me the answer so that I see it. Try to do D, send me the answer, I see it. So I'll go straight. You know, the way I have solved C, it is possible you can solve now this. You can solve F. I've given you an assignment, so you send the answer in the comment section or in my inbox if at all you have my number. So let's go ahead and you solve D. I'm waiting for the answer for D. Then I'll go ahead and solve E. Okay, or maybe you might be confused with 8 comma 9. So let me just solve for you. Okay, let me just solve for you, guys. Let me just solve for you D. So I'll shift this one a bit to be here. Let me just solve for you D. So D is saying A intersect it. B is the same as intersection C complement, like that. So here it's not something that is difficult. We are just, although it's a bit similar to part B. So A, it is -2. Okay, A is -2 all the way to 7. Not included, not included. That is my A. And then what else do we have? What is B? B is from -6 included all the way to 6 also included. But again we have to jump. That is B. We have to jump. We go to 8, 9. So 8 is just a point, 9 is just a point. That is also B. That is also B. What else? C complement. So C is 3 to 10. 3 to 10, but we don't want 3. 3 is not included, so complement will be included. Going there to 10, that is C complement. We want a point where all the 3 lines are meeting. Okay, we want a point where all the three lines are meeting, B, A, and C. So that is this point. That is this point here. That's all. So the answer should be open, because the last you look at the last one here, it is -2, comma, the last one again it is crossed, so it is 3, but included. So that's the answer for that question. So that is what? That is D. Okay, that is D. So that is it for part D. Now let's go to E. E is also a bit interesting, but let's see how interesting it is. So E is saying x. So if I'm to rewrite that x to be minus is the same as intersection C complement, and then we have got also a complement outside, intersect it with a intersection B complement. So that would mean to say it is x, okay, union. So x complement union, the sign, this one changes, then complement to just be C, like that, then and then intersection it with the same thing, like that. Yeah. So A union C, it is x union x complement. So x complement is like the universal complement. Everything in the universal will remove it. It is empty set. So empty set union C, it is just C. So this part here, it is just C. This is just C. So it's like we are finding this. This is what we are finding now. Okay. So now we are finding this. So let us first go ahead and look at B complement. Remember, my B, it is -6 to 6. So -6, since it is included, the complement is not going to be included, but the last one will be included. That will be B complement. Again, this goes all the way to 6. 6 is what? Included. So the complement is not going to be included. But again, there is a point we have to remove, exclude the 8. Again, at 8 I'll put open, at 9 I'll put open. So this is now my B complement. So even this one is B complement, B complement, B complement, like that. What else I was supposed to say? C, we're now interested in, we have got A. A is -2 all the way to 7, not included. -2, not included. 7, not included. That is A. So where else C? C is 3 all the way to 10, not included. 10 included. That is C. We want a point where the 3 of these guys are meeting. What are those points? 3 of these guys are meeting. It is at this point, the 3 of them, because it is intersection, that point. That's all. The rest, they are meeting just the 2 of them. So it is something that is not complicated. Okay, so we are just looking at a point where all of it, they are meeting. Okay, so it is basically 6 all the way to 7. Simple. So this is 6 comma 7. So what you do, guys, that is open. What you do, guys, is I want you to go ahead and look at this question. If at all I've made a mistake, you can comment, but I believe I have not made any mistake, and this should be the answer. Okay, so that is the answer. So now let us try to see. Let us try to look at the last one. Now the last one, I think you can do it because it's basically the same as part E. Try to do the part F. then you show me the answers which you are going to find. So for question 4, I end here. So try just to follow through. I think it will be it will be simple for you to solve different questions based on the same topic. Okay. So question 5 is saying, given that the set of real numbers is the universal set. The moment you hear the set of real numbers is universal set, is from negative infinity to positive infinity. A is given by negative infinity to 7 union 9 to positive infinity, and B is 5 included to positive infinity. Find each of the following sets and show them on the number line. So me, what I normally do, I just show them direct on the number line, then I find them direct. So let's start with first one, which is A complement. So when you're talking about real numbers, that's where now you put arrows. Negative infinity, okay, negative infinity to positive infinity. So I'll put negative infinity, positive infinity. Just put 0 here to demarcate, to separate positive and negative. So A is from 7. What else do we have? The numbers 7 and 9. So I'll put 7 here, I'll put 9 here. So 7 to negative infinity, 7 is included. Okay, that is A. That is A. Then again we jump 9 to positive infinity, not included. That is again A. But the question is, we want to find A complement. So A complement is the part that should not be part of A. So this is included, the complement not going to be included. This is not included, the complement will be included. This part in between is A complement. So this part is my A complement. Therefore A complement, it is in, so you follow this, it is open 7 comma the last one closed, 9 included. A complement. Then we can also go ahead and look at part B. So part B, we are talking about A. So if you bring that inside A complement intersection B complement, like that. Let's try our number line as usual. Negative infinity to positive infinity. 0 should demarcate there, separate those two things. A, so we have, in fact I don't have any negative number, so I can just do this. I don't have any negative number, right? So what I'll do is this. I'll just write this side 0. I have got 5, 7 and 9. So A is 7 to negative infinity included, negative infinity, that is A. Again 9 not included to positive infinity, that's A. Then we want, in fact we just want a complement. So in these ones I'm not interested in these, I just want a complement. A complement, we said it is starting from at 7, since 7 is included, so starting from they are not included, then 9 has to be included. We said that is A complement. What is B complement? So B itself is 5 to 7, 5 to positive infinity. So the complement is starting from here open going there. So B complement is there. So where they intersect, these two guys are not meeting, therefore these two is empty set. Let's go to the next one. A minus B. A minus B is the same as A intersection B complement. So we just need to find, let's first put our A. A is 7 included all the way there, and also where? And also where is B? Sorry, where is A again? 9 not included there, that is also A. So we go ahead and also talk about B complement. So B itself is 5 to positive infinity, 5 from here going there, but complement meaning starting from here not included to negative infinity. That is B complement, because from here all the way to that point it is my B, so I don't want that point. So I want a point where these two guys intersect, so it is here. So A minus B is basically from negative infinity. So infinity, you don't have to anything, as long as you are talking about infinity you use open. Okay, when infinity we use open, so that's why I'm using open here. Then if we go to the last part is 5 but it's not included, this becomes my answer. Let us try to crack part D, but you can pause the video, try to solve D, and also try and see how I'm going to solve it. So D is B complement intersected with A intersected with B complement, like that. Let us see. Okay, so initially what we are trying to do here, if I'm to simplify, this is the same as B complement intersection A, then this intersection will be here again, B complement intersection B, of which I want you to know that B complement intersection B complement is just B, so it also takes us back to this, so there's no need of me simplifying it, just like that. So what we'll do is I'll first write what my B first. Let's write our A. Our A is from negative infinity to 7. 7 is included here, not included. So that is A. Okay, that is A. But now B, we are interested in B complement. So B complement, it's like this. Here we know there's what we call absorption rule. There is B here, so the number that I'm going to have here, I intersect it again with B. It's the same as just A intersection B complement. It's the same thing. So basically this is the same as, it's more like, okay, let me first write B complement. I'll show you something. B complement is, B is 5 to positive infinity, but B complement will be this point not included there. So it's like this. Let me just show you something, just a bit. If I have got B complement as maybe 1, 2, 4, and let's say we have got A being equal to 1, 2, 7, maybe 8. So you realize that A intersection B complement, it is 1, 2. But again, I intersect this with again B complement, it will still be 1, 2. So this is the same as we are finding A intersection B complement, just like this. So we want where A and the B complement, they are meeting. There is no B here, forget about that point. So it is this point here. So it is actually from negative infinity to 5, 5 not included again. 5 should not be included. Okay, so that is it for question 5.